functions basically. So in the case of fuzzy set, this is what we have. So in the case of fuzzy set, what do we have? The fuzzy set is characterized by means of the membership function mu a, where it's a function from x to the closed interval 0, 1, and it is represented by a tuple, two tuple x comma mu a of x, such that where x's are coming from the universal set capital X. What does this mu a of x represents? Let us try to understand this mu a of x by means of an example. Suppose if I am defining my set of young people, right? Set of young people. Obviously, if I am defining, I'll consider my age to be included in the set of young. So it is person dependent in nature, right? Depending on the people, the set answer in the set may differ basically, right? So suppose if I am defining the person whose age is around 25 years young. So Deva, whose age is 25 years, 2 months. So his age is nearer to 25, but not exactly 25, right? So, but how the definition is defined, it's around 25. So it's very nearer to 25. So the membership value 0.8 is given. So Deva is having the membership value 0.8. What is the meaning of this 0.8? Deva is a person who satisfies the condition of being in the fuzzy set young about 80%. That is what the meaning of 0.8 refers. How much it satisfies the condition of being in the set, right? So in the case of classical sets, the number, the previous example, if you consider the number 3, for example, this satisfies the condition of being in the set of natural numbers less than 6. It's 100% satisfying the condition. But what is the case of here? Deva is a person who's satisfying the condition of being in the set n about 80%. Raju, whose age is 31, right? So which is far away from 21. So he is satisfying the condition of being in the set about 10%. These are the values which is given by me, right? This is basically the person dependent. So in what way we can understand? Again, in a layman point of view, we need to answer. Here we have answered in a layman point of view how the crisp set can be considered. It is nothing but a question that can have only one correct answer. Now we are going to consider the real life problems. For example, if I am asking you, how was the day today? What would be your each and every individual's answer? Somebody will say the day is good. Somebody will say the day was good until Jeevaraj's presentation, right? So the different people may feel the day to be different. So, and at the same time, I cannot say one person is saying the day is good. No, he is telling wrong. The day is bad, right? So it is bad. It might be bad because of my experience, right? So the question may have more than one correct answers. Just I wanted to give by means of one example which is being taken from the movie called Tangamingal. I believe that I wanted to play. So are you able to see the screen? Yeah. So I wanted to explain this idea of fuzzy sets by means of an example from a movie basically. This is a movie called Tangamingal. I strongly believe that most of the audience are able to understand Tamil. Is that okay? Anyway, I'll explain it in English as well, even if you are not able to understand this. Let me play this video. So according to you, which is costly? Now the teacher is actually trying to make the kids to know the value of big integers and smallest integers. So she's writing some 4 values on the board, like 1500 to 200, 100, and anybody can understand the language of numbers by means of money. So she is trying to ask the question to the students that which is costly, right? And most of the students are shouting, I can answer, I can answer, I can answer. So I believe that let me ask the same question to you. What would be your answer? I believe that most of you would say that 1000 is costly, right? Let us hear from the kids. Listen to her answer very carefully. So now you tell me which answer would be most appropriate answer. The previous one, all the kids were saying 1000 is costly, right? But the heroine of this particular movie, this small kid, is saying an answer. 1000 rupees is costly for my grandfather, 100 rupees is costly for my father, right? So I believe that the second answer is the most appropriate one. And why is this happening? Because what is the question? Which is costly, right? So costly is the term which is person dependent in nature, right? So according to me, some rupees is costly. So this is what I wanted to explain. So what is the meaning of fuzzy sets? The fuzzy set is something which is person dependent in nature, and we cannot say that whatever the answer which were given by the other people is wrong, right? So hereafter, if you wanted to understand what are fuzzy sets, how can you understand basically the fuzzy sets are nothing but what? The question that may have more than one correct answers, right? So I believe that you guys are able to understand it in a much better way, right? So why am I giving such kind of example? Because you need to understand what are fuzzy sets, right? And how can we understand the essence of fuzzy sets, right? For that only I'm trying. Now we are going to define. We are going to discuss about the definition of an alpha cut. Alpha cut of a fuzzy set A is defined mathematically by means of the symbol superscript alpha A, and which is defined as set of all x in capital X such that A of x greater than or equal to alpha. A of x refers the membership function, right? And what is the meaning of capital X? It's a universal set. So what is happening in the case of alpha cut? We are collecting set of all small x in universal set whose membership value is greater than or equal to alpha. Just in order to make you understand this alpha cut, let me take an example. Let us consider a trapezoidal fuzzy number ABCD. Why we are calling it as trapezoidal fuzzy number? Because the shape of the membership function is looking like trapezoid, right? So that is the reason why we call it as trapezoidal fuzzy number. Now, what is the meaning of alpha cut? Right? What is the meaning of cut? We are going to cut something, right? So we have this membership function. We are going to cut this membership function by means of a line y equal to alpha. So at how many places this line will cut to this membership function? It will cut, it will intersect at this particular point and at this particular point. What is it? What would be its inverse image? Its inverse image would be here. Let us call it as x1. This point to be x1 and this point to be x2, right? So what does this trapezoid represents? It is nothing but a of x. So what can you talk about a of x1 for this? Which is a of x1 is nothing but what? Whose value is basically equal to alpha. What is the meaning of x2? A of x2, which is also equal to alpha. Suppose let me consider some x3. Between x1 and x2, let me consider some x3. For example, my x3 is here. What would be its membership value? Its membership value means what? You need to see what is a of x3. It would be somewhere here, right? We do not know what exact value is this, but we can say that definitely this value is greater than alpha, right? So what we are, similarly, if we take x4, what would be its membership value? Its membership value is 1. Similarly, between x1 and x2, if you take any element, any xi, what can you talk about its membership value? It is basically greater than or equal to alpha. So what are we collecting in the alpha cut? We are collecting the set of all elements from the universal set. X-axis refers universal set, y-axis refers the closed interval 0, 1. Set of all elements in the universal set whose membership value is greater than or equal to alpha. In another way, we can understand alpha cut is nothing but what? It is nothing but inverse image of this closed interval alpha comma 1 under this curve, right? Inverse image of this closed interval alpha comma 1 under this curve, that is nothing but what? This closed interval. Guys, is this clear? So with respect to this particular alpha value, my alpha cut is basically the closed interval. Whether the alpha cut definition would be person dependent. Now the question is nothing but what? Fuzzy set is basically person dependent. But what can we talk about its alpha cut? Alpha cut is not person dependent. If I'm telling you the alpha value, for example, 0.7, the 0.7 cut for a particular fuzzy number would be this particular interval. If I'll ask this question to all of you would give you this closed interval, right? So the definition of alpha cut is basically a crystal set. Now, similarly, the strong alpha cut, it is defined as we are interested in collecting the elements of a universal set whose membership value is strictly greater than alpha. The difference, only difference between alpha ket and strong alpha ket is nothing but what? Here we are also collecting these x1 and x2, the closed interval. It is basically the strong alpha ket is an open interval. We are excluding only the boundary points. So this is what the difference between alpha ket and strong alpha ket. Again, those who are working in fuzzy could see the idea of alpha kets are being used in many articles for multiple purposes, right? Multiple purpose. But what is the real meaning of it? How can we understand this again? We need to understand this idea of alpha kets. Why do we need to study about alpha kets, right? For example, suppose if you are given with the 2 squared, right? Let me explain this idea by means of please don't think that why is this guy taking a lot of time in explaining the simple things. Actually, the explanation about these simple things are not available. And the understanding towards these simple things are very much important for modeling a problem. Because in this 1 hour, I cannot make the people to learn the entire fuzzy theory, but I can give the motivation for them to work in fuzzy theory. So this is what my idea. Suppose if you are given with a problem like this, can you find 2 squared? Of course, we can find 2 squared. It's 4, 2 cube, 8, 2 power 4, 16. What about 2 power 10? Yes, of course, you can calculate it 1024. But when compared with calculating 2 power 2, 2 power 10 is comparatively difficult. What about 2 power 100? Right? Definitely, one can find out 2 power 100 easy. One can find out 2 power 100. But what about the computational efforts? The computational effort is so huge, right? Now, how can you solve such kind of problem? Suppose if you are given with a problem like this, right? How do you try to solve this problem? Don't say that, sir, we can continuously calculate 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. In that way, we can go up to 2 power 100. Yes, of course, it's nothing but what the brute force way of finding it. Can we find this quantity by means of any other way? Right? If anybody have any answer, you can tell me. How can we find this value? 2 power 1000, 2 power 2024, for example, this year. Do you have any idea how can we find out such kind of values? It is possible to solve it, but it requires a lot of computational efforts. Can we use some other way of identifying this? Okay, let me answer directly. So suppose if I'm applying a function, for example, if I'm applying logarithm, right? So if I apply a function, instead, this is my original problem P, but what am I going to do? I'm going to take a log of my original problem P, log of 2 power 100. So it is easy to calculate, right? 100 log 2, and you can find out the value of log 2 and you can multiply it with 100, right? Then what can we do further? So once we are using, so now if the problem is originally in decimal domain, originally in integer domain. Now after taking log, it is changed to logarithmic domain. There we are using the log values and you are solving it. So you are solving the problem in logarithmic domain, right? So originally the problem is difficult to visualize, but when we are taking a function, logarithmic function, for example, the problem looks simpler, right? In the logarithmic domain. So in the logarithmic domain, we'll solve the problem. Once we find out the solution in the logarithmic domain, what do? We will take anti-log to know the exact value of it.